Hi, and welcome to our presentation, Opening Space for Radical Hospitality, the Science Behind the Culture of Care.
We're delighted to share a presentation today on the neuroscience of stress and kindness, which we will connect back to the pillars and principles that comprise culture of care.
I'm Amy Erickson. I'm a lead faculty development and coaching specialist, and I'm joined today by Dana Dillard, assistant professor and program chair of psychology.
Thank you for joining us today as we provide an overview of how we perceive the world and how this connects to the classroom and care.
Some of you may be wondering what we mean by radical hospitality. This is a term we've borrowed from Dr. Mays Ahmad, a professor at Connecticut College who specializes in the neurobiology of learning. She seeks to provide a safe, welcoming, and inclusive space for students to grow and learn. In fact, she frequently refers to her classrooms as learning sanctuaries. Her work has taught us that the culture of care is more than just offering flexibility in the online classroom. The culture of care is rooted in science, in neuroscience to be exact, and Dr. Dana Dillard and I thought it would be valuable to break down this science to help others share in this understanding.
Thank you, Amy. So let's start by considering how we experience the world. The world does not actually exist. Well, not the way that we think it does. Okay, I'm lying. It exists exactly as we think it does, which is kind of the problem. The world as it exists for me is very different from the world as it exists for Amy, as it exists for my boss, my instructors, for my students, for my son, and for everyone who is attending to this presentation. What exists is a brilliant, chaotic mix of waves and molecules. There is nothing real, nothing concrete, until our individual brains tease out meaning from each of those sensory inputs. That meaning is built out of the pathways that are constructed and refined across the lifespan, with early fetal influences having substantial impact on the ultimate organization of the human brain and interpretation of experience. The early development and organization of the brain may impact the degree to which we notice, attend, and respond to stimuli across our lifespan, and this may lead to very different experiences and reactions. For example, in a walk past a bakery, a passerby may notice the smell of freshly baked cinnamon raisin bread. Through the process of olfaction or smell, those odorants, the scent molecules land in a suitable environment, which is our nose, and are translated into a neural signal that becomes a series of electrical and chemical impulses racing to and through areas of the brain that correspond with emotion, memory, and body regulation. Barring disease or disorder, this process will be similar in most humans. However, the degree of connections and pathways that are present will have been shaped by a lifetime of experiences leading up to that moment. Next slide, please. Now, let's say our someone on the walk past the bakery is actually a group of friends. For one person, the landing of those odorants on the olfactory epithelium sends a cascade of messages that, in an instant, bring forth a fountain of memories, joy, and love from a childhood spent baking with a very dear grandparent. For another person, perhaps the scent is pleasant, but not attached with anyone or anything specific, but maybe they missed lunch and noticed their stomach grumbling. For a third person, perhaps the smell of cinnamon happened to accompany a very scary event, provoking an immediate and potentially uncontrolled reaction of fear, leading to freezing in place and an inability to articulate what was occurring. The group of friends are walking in the same world, with the same molecules and waves, but experiencing it very differently. So why is this important? In any given instance, we may not know how someone is experiencing the world. If the experience is rooted in a perception of threat, their response may be to fight, flee, or freeze. Although many parts of the brain are involved in these processes, two of the most commonly associated pathways with threat and stress perceptions are the sympathoadrenal medullary system, the SAM system, and the hypothalamic pituitary adrenal axis, the HPA axis. Both are regulated by the hypothalamus. The hypothalamus receives input from emotion and sensory pathways and jumps to action. These emotion pathways include bidirectional communication with the amygdala via the stria terminalis and other pathways, which correspond with fear learning and extended fear states. The bed nucleus of the stria terminalis also has connections with the insula and the paraventricular nucleus of the hypothalamus, areas associated with social emotions and experiences. Activation of the SAM system results in a release of epinephrine or adrenaline to the bloodstream, which corresponds with the physiological reactions of stress. A racing heart, increased blood pressure and breathing, sweating for some, sharpening of some sensory pathways to allow greater focus on other potential threats in the environment, release of factors designed to address immediate physical injury, and flooding of glucose into the bloodstream to feed muscle and tissue. The HPA axis will also activate under stress, and it prepares the body for potential longer periods of stress. The HPA axis, through its signaling pathways, sends cortisol, the human steroid, throughout the body, telling organs and tissues to prepare for a period of uncertain and unresolved threat. The body is designed to resolve these threats, not to stay in a continued state of arousal for an extended period. And staying in the aroused state becomes very damaging to the mind and body. Many of us are aware of the physiological dangers of stress and that stress shares a relationship with susceptibility to chronic illness, cardiovascular disease, cancer growth, autoimmune disorders, metabolic disorders, and more. But why might this be of interest in a discussion on teaching, caring, and radical kindness? For that, I will turn to Amy.
Thank you so much, Dana. Now that Dana's given an overview of the SAM system, the HPA axis, and the sympathetic nervous system, we thought it might be valuable to take a step back and share what's been learned about experiences that can have an impact on learning and memory. The Adverse Childhood Experiences Study was conducted by the Center for Disease Control in Kaiser between 1995 and 1997. In it, 17,000 adults were asked if they had experienced any of the following during their youth: emotional, physical, or sexual abuse, a maternal figure treated violently, substance abuse in the home, mental illness in the home, parental separation or divorce, incarcerated household member, or emotional or physical neglect. In 2022, Smith Battle and colleagues examined studies to include categories that had been left out of the original study. Those were exposure to community violence, economic hardship in childhood, bullying and peer rejection, absence or death of parent or significant other, and discrimination. All of these things contribute to stress to a child. The data from the survey went on to prove that there was a dose-response relationship between ACEs and health outcomes, meaning the higher your ACE score, the worse your health outcomes. The individuals with 4 or more ACEs had a much higher rate of disease and ill health. And some instructors may look at this data and think it's unrelated to their work in the classroom. After all, student health outcomes are outside of an instructor's scope of practice, and long-term health consequences could occur decades after a student is in the classroom. But what if I told you that the data is relevant, to our current work in the classroom? It's well understood that trauma has a psychological impact on individuals, and the data from the CDC now demonstrates that trauma has physiological health consequences too. But what may not be as well known is the fact that trauma and stress can impact cognition due to possible changes in brain structure and function. Study, this one by Giano and colleagues, found that the following in relation to ACE scores. Females had significantly higher ACE scores than males. Multiracial individuals had significantly higher ACEs than all other races and ethnicities. The 25 to 34-year-old age group had a significantly higher mean ACE scores than any other group, and individuals with lower income and educational attainment had higher ACE scores. Now let's look at this same group of individuals with higher ACE scores, and next to it, the UAGC population. It's also important to note, as we look at this graphic with our UAGC student population, that adult learners comprise approximately 87% of that population. Unlike traditional college students, adult learners are typically juggling multiple responsibilities like careers, families, and even military obligations. In addition to managing various responsibilities, adult learners may be returning to the classroom with additional stressors like finances or family. Neuroscientist Antonio Damasio and psychologist Bessel van der Kolk clarify that when an individual is stressed, like our adult population, the brain goes into survival mode by prioritizing what matters and conserving energy to save a life. Being in a perpetual state of fear or uncertainty, like the pandemic, results in the body being continually exposed to stress hormones, a state that neuroscientist Dr. Mazen Ahmad explains as energetically costly to an individual and renders an individual unable to focus on learning, but rather on survival. Such a state is natural, but it's not optimal for learning. As Dana noted, if the amygdala continues to alert the hypothalamus to release stress hormones, this can have an impact on learning. And Dr. Ahmad explained that this situation can impair one's ability to pay attention, make decisions, learn, and remember. She additionally reminds us that if stress is chronic, that the following three things may happen to the brain and disrupt learning. The hippocampus, which is responsible for learning and recall, could shrink. The amygdala, which determines threats to the system, could grow, making it increasingly sensitive to stress and fear. And the prefrontal cortex, which is responsible for decision-making skills, could shrink. So these structural changes can cause a decrease in attention, perception, short-term memory, and decision-making. And such physical alterations in the brain structures and function cannot be written off as purely psychological or an emotional issue, nor can they be explained away as simply a lack of resilience on behalf of the student.
As we have discussed, stress results in the activation of the sympathetic nervous system, and chronic activation of these stress responses correspond with effects on health, learning, memory, and cognition. However, our bodies have another system that operates in opposition to the sympathetic nervous system, the parasympathetic nervous system, where the sympathetic nervous system results in rapid breathing and elevated heart rate and blood pressure. Activation of the parasympathetic nervous system returns those elevated processes to their baseline. The parasympathetic nervous system helps bring the body back to a relaxed state. In fact, the purpose of many relaxation techniques is to facilitate this return to baseline or beyond for a deep state of relaxation. But of interest is why this corresponds with a discussion on kindness. Humans are social animals, and when surrounded by people we love and who love us, our bodies respond. The same region of the brain that keeps us attending to stressful situations will also release signals that correspond with anxiety reduction and social bonding. Our brain rewards us for being with those we love, trust, or feel connected to by keeping us calm, physically and emotionally. There are many caveats, and this is an oversimplification, but it has potential for informing caring interventions. As an interesting point to consider, it is not only feeling supported that may promote health. Showing empathy, compassion, and admiration corresponds with activation of areas of the brain that in turn activate areas associated with information and emotion processing, decision-making, and motivation. Expressions of kindness and providing social support may promote relaxation through indirect and direct activation of neurons in the parasympathetic nervous system. Being kind may promote a return to a baseline state and reduced stress reactivity. Being kind is good for our health too.
So knowing even a rudimentary amount of information about stress and trauma's impact on the brain really underscores the importance of embracing a culture of care. We felt that educators could benefit from understanding the impact of stress, possible origins of trauma, and the physical and cognitive consequences of both. And it's our hope that the information presented here underscores the importance of a safe online environment, a learning sanctuary that is steeped in a culture of care, a culture rooted in principles of neuroscience, demonstrating that communication, advocacy, respect, and kindness all work together to promote learning and protect health. Thank you so much for joining us today.